My dear students of CE806, this is breeze part and lesson 7. And in lesson 7 there will be two parts. And first part will be the design for the moment at section 5.
Section 5?
At section 5. The moments at section 5 are calculated moments, and the moments at section 5 are 3939 keep fit is a positive moment and minus 777 keep fit is a negative moment. First of all, we will be designing for positive moment. We will calculate the reinforcement for positive moment. This section is decided earlier. For positive moment, the beam will be designed as a T-beam. And flange width calculation, as you have learned in previous design in breeze, BW plus 16T, BW is 16 and T is 7 inch. We have decided this width and about this width and thickness of slab earlier. The spacing of the beam, and that gives us a value of 128 inch. Spacing of beam is 9 feet 4 inches, and that gives us a value of 112 inch. And L by 4 is L is 90 from section 5 to section 3. The distance is 90 feet, and that 90 divided by 4, L by 4 is 270 inch. Therefore, the minimum of these three will be the flange width. Therefore, the flange width is 112 inch. Flange thickness is 7 inch. Total thickness of the slab, as previously we have decided our slab thickness. Effective depth shown in shear calculation. We have make a detailed calculation for effective depth determination in shear calculation. You can look back to that shear calculation and you will find this effective depth as 44.5 inches. Now we will be designing for this. We will find out the steel area. As you know, as we do, first of all we take a value of A, thickness of value of A. In T-beam, normally we take the half the thickness of the slab as first choice of A, and our slab is 7 inches and the first choice is 3.5. I have taken it as a rounded figure. Instead of 3.5, I have taken it as 4 inch. And now steel area is moment in inch cube divided by 5 is 0.9, 60 is Fy, and 44.5 is the effective depth, and A by 2 is 4 by 2, and this gives us a value of 20.84 inches square as steel area. We have to check A. We have taken an arbitrary value of 4. That's why you have to check with this steel area what is the A value. Then in checking A, we have to multiply this steel area by F prime S Fs, and that should be divided by 0.85, and 4 is the concrete strength and 112 is the width of the flange width, and that gives us a value of 3.28. We have taken 4 as a choice and we have got 3.28, and that's why we have to go a little bit smaller value than 3.28, and that is a round figure. We can take this A is equal to 3 inch, and with this 3 inch A value, AS is equal to again 3939 to 12 divided by 54 divided by into 44.5 is the D, and 3 by 2 is 3 by 2, and that gives us a value, steel area value of 20.4 inches square. Now we check this one again. A value is checked and we got a value of 3.2. Is very close to the chosen one, and that's why we will keep this steel area as 20.4 inches square. We will be using here 1 by 3/8 dia bar, 1/3 dia bar, and the area of 1/3 dia bar from the chart in the appendix table 1, the area is 1.56, and we have to divide this 20.4 by 1.56, and that gives us a value of 13 numbers. And 13 number, it is odd number. First of all, we will provide 12 1/3 inch dia bar, and for the remaining one we will give, instead of number 11 bar, we will give another 1/8 inch dia bar for the remaining area, and the total will be the 12 is 1/3 inch bar and 2 is 1/8 inch bar. This combination will give us the total area of steel required. And this is T-beam design for the positive moment, and this part is complete for this T-beam portion. Now in the same section there will be a positive moment. Sometimes there will be some small positive moment in this section, because for the position of the live load, and in a certain position of the live load, there gives a negative moment of 7 feet, and for that the steel will be at the top of the beam. Steel will be at the top of the beam, and as the moment is a smaller one, there will be we believe that there will be one layer will be sufficient for reinforcement, one layer of rod, and that's why the effective depth will be much less than the effective depth is taken as 54 minus approximately 6 inches, because there will be 2 inch clear cover, half inch dia stirrup, and the 1 diameter of the bar, etc., etc. We have taken a little bit advantageous minus. We have make a bigger figure minus to be on the safe side, and that's why this effective depth we will be taking as 48 inch. And A is equal to, as this is a rectangular beam, this is a rectangular beam, we have to take approximately A value. We should choose a value, and as the moment is small, the steel area will be small. That's why we have chosen A value as 4. And normally I have taught in the general class that if normal beam is to be designed for tension steel, then we take the A value as 1/4 of the depth of the beam. But here the moment, as I know, in comparison with the moment, in comparison with the section of the beam, the moment is a little smaller. That's why we have taken it is almost say about 54. The effective the A value is taken. A value is taken as 4, and the steel area AS equation, in AS equation we have put 777 moment multiplied by 12, and that divided by 0.9 is 5 factor, and 60 is Fy, and 48 is the 48 is the effective depth. 48 is the effective depth, and 2 is A by 2. 2 is A by 2, and that gives us a value of 3.75 inch square. And in checking A for this with this steel area, 3.75 into 60 divided by 85 is 85 factor, and the 4 is concrete strength and 16 is the width of the beam. Then that gives us a value of 4.1. We have chosen A as 4, and we got here 4.1. It's very close. That's why here we will stop and we will use this 3.75 as our steel area for the positive moment. And if we use 1/4 inch dia bar, then area will be 1.37, and there will be three number of bars will be required, and those will be placed at the top of the beam. And this much about this section 5, steel calculation. and thank you very much for the day.